Planet Venus. Venus, often referred to as Earth's twin, stands as one of the most fascinating and mysterious celestial bodies in our solar system. From the time ancient astronomers first gazed at the night sky to the sophisticated space missions of the modern age, Venus has captivated the human imagination. Named after the Roman goddess of love and beauty, the planet carries a legacy of cultural significance, mythological importance, and scientific intrigue. Despite its alluring name and glowing presence in the heavens, Venus is far from gentle. It is a world of extremes: blistering temperatures, crushing atmospheric pressure, acid-filled clouds, and volcanic landscapes unlike anything we know on Earth. For scientists, explorers, and dreamers alike, Venus represents both a challenge and an opportunity to understand the dynamics of planetary evolution, habitability, and the delicate balance that allows life to flourish on Earth. When we observe Venus from our planet, it appears as one of the brightest objects in the sky, second only to the sun and the moon. Its brilliance has earned it the nickname the morning star when it rises before dawn and the evening star when it shines after sunset. Unlike many other planets that can appear faint or distant, Venus has a steady, dazzling glow that makes it unmistakable. Early civilizations interpreted this radiant point of light in countless ways, often associating it with deities and spiritual forces. Ancient Babylonians, Greeks, Mayans, and Egyptians recorded its movements with precision, developing myths and astrological systems around its presence. To them, Venus was more than a planet. It was a messenger of fate, a symbol of rebirth, and a celestial body that dictated rhythms of life on Earth. Yet, behind this brilliance lies a reality that is shockingly hostile. Venus is not a paradise, but a hellish world cloaked in thick layers of carbon dioxide and sulfuric acid clouds. Its surface temperature soars to around 465 degrees Celsius, nearly 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is about 92 times greater than Earth's, comparable to being nearly a kilometer beneath the ocean. This combination makes Venus one of the most inhospitable planets in the solar system. And yet, paradoxically, it is precisely this extremity that makes it a key subject of study for scientists. By unraveling the secrets of Venus, we gain insights into climate change, atmospheric chemistry, geology, and the boundaries of life itself. The planet is also geologically active. Radar images obtained by missions such as NASA's Magellan spacecraft reveal mountains, plains, canyons, and massive volcanoes. In fact, Venus hosts some of the largest volcanic structures in the solar system. These features indicate that volcanic processes may have shaped much of its surface. Unlike Earth, however, Venus lacks plate tectonics, the system of shifting plates that drive earthquakes and mountain building. Instead, it seems that Venus periodically undergoes a resurfacing process, where large portions of its crust are reshaped by volcanic activity. This raises intriguing questions. Is Venus still volcanically active today? Does it experience planet-wide eruptions that reset its geological clock? And how do these processes compare to Earth's more familiar systems? Another mystery lies in Venus's atmosphere. Its clouds, while beautiful in ultraviolet images, are composed largely of sulfuric acid droplets. These clouds not only reflect sunlight, contributing to Venus's dazzling appearance, but also trap heat in a runaway greenhouse effect. Scientists often use Venus as a cautionary tale when discussing climate change on Earth. Billions of years ago, Venus may have had liquid water and more temperate conditions. But over time, as the sun grew brighter and greenhouse gases accumulated, the planet spiraled into its current fiery state. This transformation warns us of how delicate planetary climates can be and how even a slight imbalance can lead to catastrophic change. Studying Venus, therefore, is not just about understanding another planet. It is about safeguarding our own. In addition to its scientific mysteries, Venus also inspires visions of exploration. Over the decades, both the Soviet Union and NASA sent probes to study the planet. The Soviet Venera missions achieved historic firsts by landing on the surface, capturing images, and transmitting data back to Earth, though only for a few minutes before the intense conditions destroyed them. More recently, Interest in Venus has been renewed, with proposed missions aiming to study its atmosphere, climate, and geology in greater depth. Some even imagine floating cities in the upper atmosphere of Venus, where conditions are surprisingly more Earth-like. Around 50 kilometers above the surface, temperatures and pressures are much more moderate, suggesting that future human habitats might one day hover above the deadly surface below. Venus, then, is a planet of contrasts, a radiant jewel in the sky, yet a furnace of destruction on its surface, a symbol of love and myth, yet a reminder of planetary fragility in science. As we continue our journey to understand this enigmatic neighbor, Venus challenges us to expand our knowledge, refine our technology, and rethink what it means to explore the cosmos. It forces us to confront questions not only about other worlds but about our own, about climate, survival, and the balance that sustains life. The mythology of Venus stretches across civilizations, cultures, and centuries, making it not only a scientific wonder, but also a deeply cultural and spiritual symbol. Ancient people had no telescopes, no spacecraft, and no scientific instruments to measure the nature of this glowing object in the sky, but they were keen observers of patterns. They noticed how Venus appeared regularly before sunrise and after sunset, never straying far from the sun. Because of its brightness and rhythmic cycles, they gave it divine qualities, associating it with fertility, beauty, war, and rebirth depending on cultural interpretation. The Babylonians, one of the earliest civilizations to record astronomical movements, associated Venus with the goddess Ishtar, a deity of love, war, and fertility. In their mythology, Venus's morning and evening appearances symbolize cycles of death and resurrection, and its eternal return. The Mayans, too, were fascinated by Venus, incorporating its cycles into their complex calendar system. They even planned wars and ceremonies based on its position in the sky, believing the planet had a direct influence on earthly events. For the Greeks, Venus was Aphrodite, the goddess of beauty and love, while the Romans later adopted this goddess under the name Venus. Her celestial counterpart became a timeless emblem of allure and power. These interpretations highlight how deeply human beings connected the visible heavens with the rhythms of life and society. Interestingly, for centuries, many civilizations believed the morning star and the evening star were two separate objects. It wasn't until ancient Greek philosophers and astronomers like Pythagoras recognized that both were the same planet, just appearing at different times of day, that this mystery was resolved. This discovery deepened humanity's awe of the planet, solidifying its place as one of the most important objects in the sky. The mythology and cultural narratives surrounding Venus remain a testament to the human tendency to weave stories from observation, blending science, spirituality, and imagination. While mythology painted Venus as a symbol of beauty, modern science revealed a reality that is far more terrifying. One of the most striking features of Venus is its atmosphere, a thick, suffocating blanket that hides its surface from view. For centuries, even with the invention of telescopes, astronomers were unable to see beyond its dense cloud cover. This shroud gave rise to speculation. Was Venus a lush jungle world, perhaps filled with alien life? Many writers of the 19th and early 20th centuries imagined Venus as a twin Earth covered in oceans or tropical forests. The truth, revealed only through the advent of space exploration, shattered these fantasies. Instead of a paradise, scientists discovered a world that is the epitome of atmospheric extremity. The Venusian atmosphere is composed of about 96.5% carbon dioxide, with nitrogen making up most of the remaining portion. Trace amounts of sulfur dioxide, water vapor, carbon monoxide, argon, and other gases are also present. However, it is not the composition alone that makes Venus's atmosphere unique, but its thickness and the resulting greenhouse effect. The pressure at the planet's surface is around 92 bar, meaning it is equivalent to being nearly 900 meters underwater on Earth. For any spacecraft or human to withstand this pressure requires extraordinary engineering. But it is the greenhouse effect that transforms the planet into a true inferno. The carbon dioxide traps heat so effectively that Venus becomes the hottest planet in the solar system, even hotter than Mercury, which lies closer to the Sun. The average surface temperature of Venus is a staggering 465 degrees Celsius, about 900 degrees Fahrenheit. This is not just a daytime maximum, it is the constant temperature across the entire planet, day and night, poles and equator. Unlike Earth, where temperatures vary with seasons, geography, and time of day, Venus maintains a uniform furnace-like climate. This happens because its thick atmosphere distributes heat evenly across the globe. The concept of a runaway greenhouse effect is often used to describe Venus's climate, where feedback loops, such as the trapping of heat by greenhouse gases, spiraled out of control and turned what might once have been a habitable planet into a searing wasteland. Above the crushing lower atmosphere lies the cloud deck, stretching from about 45 to 70 kilometers in altitude. These clouds are composed mainly of sulfuric acid droplets, which are highly corrosive and toxic to life as we know it. The clouds reflect a large portion of sunlight, giving Venus its dazzling brightness when seen from Earth. However, these same clouds also make direct imaging of the surface impossible in visible light, forcing scientists to rely on radar and infrared instruments to penetrate the veil. What lies beneath these clouds is a world alien and forbidding, sculpted by volcanic plains, mountains, and vast lava flows. Despite the inhospitable conditions, the atmosphere of Venus is not entirely without interest for astrobiologists. At altitudes of around 50 to 60 kilometers, conditions become surprisingly moderate. Temperatures range from about 30 to 70 degrees Celsius, and pressure levels are similar to those found on Earth's surface. While still far from ideal, this zone has led scientists to speculate whether microbial life might exist in the Venusian clouds, perhaps within droplets or floating free. Although no direct evidence of life has been found, this idea was reignited in 2020 when researchers reported detecting phosphine, a gas on Earth often associated with biological activity, in Venus's atmosphere. Though the discovery remains debated and controversial, it has re-sparked curiosity about the possibility that Venus, despite its hellish surface, might harbor niches of habitability. The winds in Venus's upper atmosphere present another striking phenomenon: superrotation. While the planet itself rotates very slowly, one Venusian day lasts 243 Earth days, its upper atmosphere races around the planet in just 4 Earth days. These winds, reaching speeds of up to 360 kilometers per hour, 224 miles per hour, whip the clouds into massive swirling patterns. The cause of this atmospheric superrotation is still not fully understood, though it is believed to be linked to complex interactions between solar heating, atmospheric dynamics, and planetary rotation. Whatever its cause, it creates one of the most dramatic weather systems in the solar system, with hurricane-like forces occurring constantly across the skies of Venus. From a scientific perspective, Venus's atmosphere is both a laboratory and a warning. By studying its runaway greenhouse effect, we gain critical insights into the potential future of Earth if climate systems are pushed beyond their natural balance. The dense, hot, acidic clouds remind us of the fragility of habitable conditions and how quickly a planet can shift from moderate to uninhabitable. Venus stands as a natural experiment in climate extremes, one that continues to fascinate researchers and policymakers alike. When scientists first penetrated the dense veil of Venus's clouds using radar mapping, they uncovered a surface that was both alien and strangely familiar. Beneath the sulfuric acid clouds lay vast plains, towering mountains, enormous volcanoes, and deep canyons. Unlike the barren craters that dominate Mercury or the red deserts of Mars, Venus's surface seemed geologically young, shaped by dynamic processes that hinted at an active and restless planet. In fact, radar images from NASA's Magellan mission in the early 1990s revealed that about 80% of Venus's surface consists of smooth volcanic plains, suggesting that the planet has been resurfaced in the relatively recent past. This discovery challenged long-held assumptions and made Venus one of the most geologically intriguing bodies in our solar system. Volcanism is the defining feature of Venus's geology. The planet hosts some of the largest volcanoes known, dwarfing most found on Earth. For example, The massive volcanic structure called Mont rises about 8 kilometers high and stretches across hundreds of kilometers of terrain. Other enormous volcanic complexes, such as Sapaz Mons and Ozamons, are spread across Venusian landscapes, their lava flows stretching for thousands of kilometers. These features suggest that volcanic activity has played a dominant role in shaping the planet's surface. Unlike Earth, which recycles its crust through plate tectonics, Venus appears to lack shifting plates. Instead, the planet undergoes a unique process in which vast regions may be periodically buried by lava flows, essentially resetting the surface. Evidence also points to relatively recent volcanic activity. Some areas mapped by radar show flows that appear geologically young, lacking the dense impact craters that cover older terrain. Crater counts themselves tell another story. Compared to bodies like Mercury or the Moon, Venus has far fewer craters, suggesting that its surface is not ancient but has been renewed within the last 300 to 500 million years. Even more compelling, in 2023, scientists using radar data announced that they had detected changes on the surface near a volcanic vent, possibly evidence of an eruption that occurred in the past 3 decades. If confirmed, this would mean Venus is not just a planet shaped by ancient volcanism, but one still active today. Beyond volcanoes, Venus is also marked by other striking landforms. Maxwell Montes, the tallest mountain range on Venus, soars about 11 kilometers above the surrounding plains, higher than Mount Everest. This range, located near the planet's North Pole, is named after physicist James Clerk Maxwell and is one of the few features visible in radar images with a brightness suggesting unusual surface composition, possibly due to metallic frosts such as pyrite that condense in the cooler upper elevations. Meanwhile, massive rift valleys like Diana Chasma stretch across the surface, resembling the great continental rifts of Earth, but on a far larger scale. These features may be the result of intense crustal stress caused by internal heat struggling to escape the planet's interior. Craters, though relatively sparse, provide further clues to Venus's history. Because the planet's thick atmosphere prevents smaller meteors from reaching the surface, only larger impacts create craters, and even then they often result in unusual structures. Many Venusian craters are surrounded by flower-like splashes of ejected material, flattened by the crushing pressure of the atmosphere. Others appear distorted, as if lava flows or tectonic activity reshaped them after impact. The scarcity of craters compared to other rocky worlds indicates that much of Venus's surface was resurfaced relatively recently, likely through massive volcanic outpourings rather than gradual tectonic processes. The geological mysteries of Venus did not come easily to light. For centuries, its opaque clouds prevented astronomers from directly viewing the surface. It wasn't until the mid-20th century, when the space race accelerated planetary exploration, that humanity first glimpsed the reality of Venus. The Soviet Union took the lead, launching a series of missions under the Venera program. In 1967, Venera 4 became the first spacecraft to successfully transmit data from within another planet's atmosphere. Although it was crushed before reaching the surface, it revealed for the first time the thick carbon dioxide atmosphere and extreme pressures of Venus. A few years later, Venera 7 made history in 1970 as the first spacecraft to transmit data from the surface of another planet. Though it survived for only 23 minutes before succumbing to the furnace-like conditions, it confirmed the planet's hellish temperatures and pressures. The Soviets continued to push the boundaries, with Venera 9 in 1975 becoming the first mission to send back photographs from the surface of another planet. The images revealed a barren, rocky landscape under a dim orange sky. Later Venera missions, including Venera 13 in 1982, provided color images and chemical analysis of surface rocks, revealing that they were similar to basalt found on Earth. These missions remain some of the most daring achievements in space exploration, given the extreme engineering challenges of landing on Venus. In the 1990s, NASA's Magellan spacecraft revolutionized our understanding of Venus. By using synthetic aperture radar, Magellan mapped 98% of the planet's surface in unprecedented detail, producing global images that revealed volcanoes, mountains, rifts, and plains. It confirmed the dominance of volcanic resurfacing and showed that Venus lacked the kind of plate tectonics we see on Earth. Magellan's data continues to shape planetary science today, forming the foundation for many theories about Venus's evolution and geology. Studying the geology of Venus is more than just an exercise in curiosity. By comparing it with Earth, scientists gain insights into why two similar-sized planets, formed in the same solar neighborhood, evolved so differently. Why did Earth develop plate tectonics, oceans, and a stable climate, while Venus turned into a volcanic greenhouse? Why does Venus lack a magnetic field strong enough to shield it from solar radiation? These questions are not merely about Venus. They are about the delicate balance that allowed Earth to remain habitable while its twin became a world of fire and acid. One of the most unusual and fascinating aspects of Venus lies in its motion through space, its orbit around the Sun, and its strange, almost contradictory rotation. On the surface, Venus seems like Earth's twin in size and structure, but when we examine its day and year, we discover behaviors unlike any other planet in our solar system. These peculiar characteristics not only make Venus stand out but also raise questions about its history, evolution, and the violent processes that might have shaped its past. Venus orbits the Sun at an average distance of about 108 million kilometers, 67 million miles, placing it as the second planet from the Sun. Its orbital path is nearly circular, with an eccentricity so small that its orbit is closer to a perfect circle than that of any other planet. This means Venus's distance from the Sun does not vary significantly, and as a result, it receives a steady and intense amount of solar radiation. Because of its proximity, Venus receives nearly twice as much solar energy as Earth, which has profound implications for its climate and atmospheric processes. Its orbital period, the length of its year, is 225 Earth days. This means Venus completes one trip around the Sun in about 2/3 of an Earth year. At first glance, this might not seem unusual, but the real strangeness lies in how Venus spins on its axis. Unlike most planets, which rotate from west to east, Venus rotates retrograde, meaning it spins in the opposite direction to most planets, including Earth. On Venus, the Sun would appear to rise in the west and set in the east, completely backward compared to what we experience on Earth. Even more perplexing is the speed of this rotation. Venus rotates extremely slowly. One complete rotation takes about 243 Earth days, making its day longer than its year. To put it simply, a single day on Venus lasts longer than an entire Venusian year. But the puzzle does not end there. Due to its retrograde rotation and orbital motion around the Sun, the length of a solar day, the time it takes for the Sun to return to the same position in the sky as seen from Venus's surface, is about 117 Earth days. This odd relationship means that a person standing on Venus, if they could survive the conditions, would experience just 2 sunrises and 2 sunsets during the course of a Venusian year. The planet's bizarre rotation cycle remains one of the great mysteries of planetary science. Why does Venus rotate so slowly and in the wrong direction? The leading theories suggest that Venus may have undergone a catastrophic collision in its early history, possibly with a large protoplanet, which could have altered its spin dramatically. Another possibility is that the planet's thick atmosphere and tidal interactions with the Sun gradually slowed and reversed its rotation over billions of years. Whatever the cause, the result is a rotational behavior unlike anything else in the solar system, a planetary oddity that continues to baffle scientists and inspire new theories. Venus's orbital and rotational dynamics also affect its relationship with Earth. Interestingly, Venus and Earth share a curious resonance. Every 8 Earth years, Venus completes 13 orbits around the Sun, while Earth completes exactly 8. This 8-13 resonance means that Venus and Earth return to nearly the same relative positions in their orbits every 8 years, forming a repeating cycle. Ancient astronomers noticed this pattern without the benefit of modern science, and it contributed to Venus's role in mythology and calendars. To the human eye, Venus's appearances in the morning and evening sky seem to follow a predictable rhythm, creating an almost poetic dance with Earth that has been celebrated for millennia. Because of this resonance, Venus is often referred to as Earth's sister planet. The two are nearly identical in size, with Venus measuring about 12,104 kilometers in diameter, just slightly smaller than Earth's 12,742 kilometers. Their masses and densities are also remarkably similar, suggesting they formed from similar materials and processes in the early solar system. And yet, despite these similarities, their evolutionary paths diverged dramatically. While Earth developed oceans, continents, and a life-sustaining atmosphere, Venus became a greenhouse furnace with an atmosphere that suffocates and scorches. Understanding why two such similar planets ended up so different is one of the central questions of comparative planetology. The relationship between Venus and Earth is not just symbolic, it has practical significance for exploration. Venus's proximity makes it one of the easiest planets to reach with spacecraft, requiring less energy than missions to Mars or the outer planets. Historically, this made Venus the target of many early space missions, especially during the Cold War. In fact, Venus was the first planet visited by a spacecraft, and the first on which humanity achieved a successful landing. This accessibility continues to drive interest in Venus exploration today, as it represents a nearby world where we can test new technologies, study climate systems, and search for clues about planetary evolution. Another aspect of Venus's motion that fascinates astronomers is its lack of a significant tilt. Earth's axis is tilted about 23.5 degrees, which gives us seasons as different hemispheres receive varying amounts of sunlight throughout the year. Venus, however, has an axial tilt of just 2.6 degrees, meaning it experiences almost no seasonal variation. Combined with its slow retrograde rotation and thick atmosphere, this makes Venus's climate remarkably uniform. Every region of the planet is subjected to the same crushing heat and atmospheric pressure, regardless of latitude or time of year. These orbital and rotational characteristics make Venus one of the most peculiar planets in the solar system. Its year is shorter than its day, its sun rises in the west instead of the east, and its skies blaze with an unchanging furnace-like glow. To us on Earth, accustomed to the rhythm of days, seasons, and years, Venus challenges our very notion of time and planetary cycles. It stands as a cosmic reminder that what seems normal on Earth is just one possibility among countless others in the universe. The atmosphere of Venus is one of the most hostile and fascinating environments in the solar system. While Earth's atmosphere nurtures life, balancing oxygen, nitrogen, and greenhouse gases in delicate harmony, Venus's atmosphere has spiraled into an extreme greenhouse nightmare. Its composition, structure, and behavior make it an extraordinary case study, both in terms of scientific curiosity and as a warning for our own planet's future. As noted earlier, the atmosphere of Venus is composed primarily of carbon dioxide, 96.5%, with nitrogen making up most of the remainder and trace amounts of sulfur dioxide, argon, water vapor, and other gases. This heavy blanket of carbon dioxide is the central driver of the runaway greenhouse effect that makes Venus the hottest planet in the solar system. Sunlight penetrates the clouds and warms the surface, but the thick atmosphere traps the heat so effectively that it cannot escape back into space. Over billions of years, this self-reinforcing cycle has led to surface temperatures averaging around 465 degrees Celsius, 900 degrees Fahrenheit, hot enough to melt lead, zinc, and tin. The structure of Venus's atmosphere is layered and dynamic. Near the surface, the pressure is about 92 times greater than Earth's, equivalent to standing a kilometer underwater in Earth's oceans. This crushing pressure alone makes survival impossible for humans or conventional machines. Rising higher into the atmosphere, the pressure and temperature gradually decrease until about 50 to 60 kilometers above the surface, where conditions are surprisingly more Earth-like. At this altitude, the pressure is roughly similar to sea level on Earth, and temperatures range from 30 degrees Celsius to 70 degrees Celsius, a stark contrast to the inferno below. This zone has been called the habitable zone of Venus's atmosphere, and it has sparked imaginative proposals for floating research stations or even colonies suspended in giant airships above the hostile surface. The clouds of Venus are another defining feature. Extending from about 45 to 70 kilometers in altitude, They are composed mainly of sulfuric acid droplets mixed with water vapor. These clouds are highly reflective, bouncing about 75% of incoming sunlight back into space, which accounts for Venus's dazzling brightness when viewed from Earth. To the naked eye, Venus appears as a steady, radiant point of light, brighter than any star in the night sky. However, these same clouds make direct observation of the surface impossible in visible light, forcing scientists to rely on radar, infrared, and other wavelengths to study what lies beneath. The clouds are not serene layers, but instead are in constant motion, driven by powerful atmospheric dynamics. Venus's atmosphere exhibits the phenomenon of superrotation, while the planet itself rotates very slowly. Once every 243 Earth days, the upper atmosphere circles the planet in just 4 Earth days. Winds in this region can reach speeds of 360 kilometers per hour, 224 miles per hour, far surpassing the fastest hurricanes on Earth. These winds create massive streaks and swirling patterns in the clouds, visible in ultraviolet imaging from spacecraft. The exact mechanism behind superrotation remains a mystery, though it likely involves complex interactions between solar heating, planetary rotation, and atmospheric waves. Beneath the cloud tops, conditions remain turbulent. Although the winds slow down closer to the surface, the crushing pressure makes even modest winds incredibly powerful. At ground level, a gentle breeze on Venus would exert force equivalent to a gale on Earth. Combined with the scorching temperatures, this creates an environment of unimaginable hostility. Another dramatic phenomenon in Venus's skies is the presence of lightning. Spacecraft such as the Soviet Venera probes and later missions like NASA's Pioneer Venus orbiter reported electrical discharges in the atmosphere. These flashes of lightning are thought to be generated by turbulence within the thick clouds, similar to thunderstorms on Earth, but magnified by the density and chemistry of the Venusian air. The possibility of volcanic lightning, caused by eruptions injecting material into the atmosphere, adds further intrigue, especially if Venus is still volcanically active. From a scientific perspective, the most significant aspect of Venus's atmosphere is its role as an extreme example of the greenhouse effect. Many scientists believe that Venus may once have been more Earth-like, with liquid water on its surface. However, as the sun gradually brightened over billions of years, more water evaporated into the atmosphere. Water vapor, a potent greenhouse gas, trapped more heat, which accelerated evaporation in a runaway cycle. Eventually, Venus lost its oceans completely. Without water to regulate its climate and trap carbon in rocks through weathering, carbon dioxide built up unchecked in the atmosphere, leading to the suffocating and fiery conditions we see today. This runaway greenhouse effect on Venus is not just a planetary curiosity, it is a profound warning for Earth. Although Earth is nowhere near the conditions of Venus, the study of its climate illustrates how fragile planetary systems can be. Greenhouse gases, when allowed to accumulate, can destabilize climates and trigger catastrophic change. For Earth, understanding Venus helps us place our own climate crisis into a broader planetary context. Venus demonstrates the ultimate consequence of an unchecked greenhouse effect, showing what happens when feedback loops spiral out of control. The comparison between Earth and Venus has therefore become central to planetary science. While Earth maintains a delicate balance of gases that allow life to flourish, Venus embodies the worst-case scenario of climate gone wrong. Studying its atmosphere provides critical data for climate models, not only for Earth, but also for exoplanets beyond our solar system. As astronomers discover thousands of planets orbiting distant stars, many of them similar in size to Earth and Venus, understanding how atmospheres evolve into habitable or uninhabitable states becomes essential. Venus, in this way, serves as both a neighbor and a laboratory for understanding the universe. In addition, Venus's atmosphere has become a subject of astrobiological curiosity. Although the surface is entirely inhospitable, the temperate layer of the atmosphere around 50 kilometers above ground has sparked speculation about whether microbial life could survive there. In 2020, researchers reported the detection of phosphine gas in Venus's atmosphere, a molecule often associated with biological activity on Earth. While this finding remains controversial and subject to debate, it has reignited interest in the possibility that Venus might host life in its clouds. Whether biological, chemical, or geophysical in origin, such discoveries highlight how much remains unknown about this nearby world. In the end, Venus's atmosphere represents both beauty and danger, beautiful in its shimmering brightness, its swirling clouds, and its mysteries, but dangerous in its suffocating heat, crushing pressure, and acid-filled storms. For Earth, Venus is more than a sister planet. It is a mirror reflecting what might have been, and a cautionary tale about the consequences of atmospheric imbalance. Exploring Venus has always been one of the greatest challenges in planetary science. Unlike the Moon or Mars, where spacecraft can survive for years or decades, Venus destroys almost everything that dares to touch its surface. With surface temperatures hot enough to melt lead, atmospheric pressures crushing enough to flatten submarines, and corrosive sulfuric acid in its skies, Venus represents the ultimate endurance test for both technology and imagination. And yet, despite these challenges, humanity has repeatedly turned its gaze toward this fiery world, sending dozens of missions in search of answers. The first serious efforts to explore Venus came during the Cold War space race. The Soviet Union, eager to claim milestones in planetary exploration, launched the Venera program in the 1960s. After a string of early failures, these missions gradually achieved historic breakthroughs. In 1967, Venera 4 became the first spacecraft to successfully enter the atmosphere of another planet and transmit data back to Earth. Though it was crushed before reaching the surface, it revealed for the first time the true composition and density of Venus's atmosphere. A few years later, in 1970, Venera 7 made history as the first spacecraft to land on another planet and send back signals from its surface. It survived for just 23 minutes before succumbing to the extreme heat, but in that time it confirmed the scorching conditions that had long been suspected. The Soviet Union continued to build on these successes. In 1975, Venera 9 became the first spacecraft to return images from the surface of another planet. The black-and-white photographs showed a rocky, barren plain under a dim, orange sky, giving humanity its first direct glimpse of Venus's alien landscape. Later missions like Venera 13 in 1982 sent back color images and even managed to analyze the chemical composition of surface rocks, revealing similarities to basalt found on Earth. These achievements were nothing short of extraordinary, considering that each lander survived only about 1 to 2 hours before being destroyed. At the same time, NASA and other space agencies also contributed to Venus exploration. The Pioneer Venus Orbiter in 1978 studied the planet from orbit, mapping its atmosphere, ionosphere, and magnetic field. The most significant leap came in 1989 with NASA's Magellan mission, which used radar imaging to pierce the planet's thick cloud cover. Over 4 years, Magellan mapped 98% of Venus's surface, providing detailed images of its mountains, plains, rifts, and volcanoes. This mission revolutionized our understanding of Venusian geology, confirming the dominance of volcanic processes and the absence of plate tectonics. Despite these successes, Venus exploration slowed in the late 20th century. Mars, with its potential for habitability and its more accessible conditions, began to dominate the focus of planetary science. Venus, often labeled as too difficult, faded somewhat from the spotlight. Yet in recent years, interest has returned with renewed vigor. The discovery of possible phosphine gas in the atmosphere in 2020, along with growing interest in comparative planetology, has reignited the desire to explore Venus. Several ambitious missions are now planned for the near future. NASA is developing Veritas, Venus emissivity, radio science, in SAR, topography, and spectroscopy, a mission set to map the surface of Venus with high-resolution radar and study its geologic history. Another NASA mission, Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, aims to plunge through the atmosphere, analyzing its composition and capturing detailed images of the surface as it descends. Meanwhile, the European Space Agency is preparing Envision, a mission that will complement NASA's efforts by studying the planet's geology, atmosphere, and interactions with space. Together, these missions mark the beginning of a new era of Venus exploration, one that promises to answer questions about volcanism, tectonics, climate, and possible habitability. But the challenges remain immense. Any attempt to land on Venus must contend with conditions more hostile than almost any other environment in the solar system. Electronics must be shielded against temperatures of 465 degrees Celsius, and materials must withstand both crushing pressure and corrosive chemicals. Current technology limits the lifespan of landers to just a few hours, though scientists are developing new heat-resistant materials and electronics that could extend this survival time. Future Venus landers may carry instruments capable of functioning for days or even weeks, offering unprecedented insights into the surface environment. Beyond robotic exploration, the idea of human missions to Venus has captured imaginations. While landing humans on the surface is considered impractical with current technology, some scientists and engineers have proposed the concept of floating cities in the Venusian atmosphere. About 50 kilometers above the surface, conditions are surprisingly Earth-like, with pressures and temperatures similar to those at sea level on Earth. In this zone, large airships filled with breathable air, lighter than the surrounding carbon dioxide, could float naturally. These airships could serve as research stations or even permanent habitats, allowing humans to live in the sky of Venus while avoiding the deadly surface below. NASA's HAVOC project, High-Altitude Venus Operational Concept, has outlined such possibilities, envisioning robotic precursors followed by crewed airships exploring Venus's atmosphere. Although still theoretical, the concept highlights how even the most hostile worlds can inspire creative solutions for exploration. If realized, floating habitats could open a new frontier in human space exploration, with Venus becoming not just an object of study, but a place where humans might one day reside, suspended in the clouds of Earth's fiery twin. The future of Venus exploration is therefore poised at a turning point. With new missions on the horizon, advances in technology, and growing interest from both scientists and visionaries, Venus is no longer the forgotten planet of the solar system. Instead, it is once again emerging as a key target for discovery, offering lessons about planetary evolution, climate change, and the possibilities of life in the most unexpected places. Venus is a world of contradictions. It is Earth's closest planetary neighbor and yet one of the most hostile environments in the solar system. Its shimmering brilliance has long inspired poets, dreamers, and astronomers, but beneath that beauty lies a furnace of crushing pressure, poisonous skies, and a surface reshaped by fire. To understand Venus is to confront both the fragility of habitability and the resilience of exploration. From ancient mythology to modern science, Venus has captured human imagination. In cultures across the world, the planet's brightness made it a symbol of beauty, love, and divinity. The Greeks and Romans associated it with their goddess of love. The Maya tracked its movements as an omen of war and change, and ancient astronomers from Babylon to China carefully recorded its cycles. Even without telescopes, Venus commanded respect as a celestial beacon. Yet only in the past century did we begin to pierce its veil and discover that this morning star is not a paradise, but a nightmare world. Science has transformed Venus from a distant light in the sky into a complex and fascinating laboratory. Its runaway greenhouse effect offers a chilling warning of how fragile climates can be. Its volcanic plains tell of geologic activity that may still continue today. Its atmosphere, dense and dynamic, is a puzzle that challenges our models of weather and circulation. And within its acidic clouds, the possibility of exotic life forms, even if only microbial, forces us to reconsider the boundaries of habitability. Venus teaches us not only about itself, but also about Earth, Mars, and countless exoplanets orbiting other stars. In many ways, Venus is a mirror, showing us what happens when a planet much like Earth takes a different evolutionary path. Billions of years ago, Venus may have had oceans and conditions suitable for life. If true, then somewhere along the way, its destiny diverged. Understanding how and why this happened may provide critical insights for humanity's future. As Earth faces rising carbon dioxide levels and climate change, Venus stands as the ultimate example of a greenhouse effect taken to its extreme. To study Venus is therefore not only a matter of scientific curiosity, but of survival and foresight. Culturally, Venus has remained an icon. Its name adorns works of art, literature, music, and film. Its mystery has been woven into stories of love, destruction, and rebirth. In science fiction, Venus has alternated between depictions of a lush tropical paradise and a deadly inferno, reflecting humanity's evolving understanding of the cosmos. Today, as we dream of space exploration beyond Mars, Venus once again appears in futuristic visions, floating cities in its clouds, advanced robotic outposts on its surface, and even terraforming concepts that would remake it into a habitable world. Whether these remain dreams or become realities, Venus inspires both awe and ambition. The next decades promise to transform our relationship with Venus. With NASA's Da Vinci Plus and Veritas missions, ESA's Envision, and potential missions from other nations, we are on the verge of a renaissance in Venus science. Each mission will peel back another layer of mystery, from its geological past to its atmospheric chemistry. These discoveries may one day make Venus not only a planet we observe from afar, but a world we explore more deeply, learning lessons that will guide humanity's journey across the solar system. Ultimately, Venus is not just a planet. It is a story of beauty and danger, of triumph and tragedy, of questions and quests. It is the story of how worlds can look alike and yet be profoundly different. It is the story of how human curiosity dares to challenge even the most unforgiving environments. And it is the story of how a bright point of light in the morning sky can lead us to reflect on our own place in the universe. As the morning and evening star, Venus rises and sets, reminding us that exploration is both endless and cyclical. We have only begun to scratch the surface of its mysteries, but already it has taught us so much. In its brilliance, we see our hopes. In its fury, we see our warnings. And in its mystery, we find the eternal spark that drives humanity to look up at the night sky and ask, what lies beyond?